This is the June 2010 Higher Non-Calculator paper. Question 1 asks us to simplify this expression. There are 4 terms. First of all, we have our x terms. So highlighted the plus in front of the 2x. That belongs to the 2x. The y terms are positive 9y and negative 3y. So, if we do 6x plus 2x, we get 8x. And if we do 9y, take away 3y, we get 6y. So our final answer is 8x plus 6y. Here we are being asked to make a stem and leaf diagram. The numbers are all 2 digits, so we are going to make the first digit the stem and the second digit the leaf. So for instance, we might have a stem of 5 and a leaf of 8, meaning 58. So we go through all our numbers and look for an appropriate stem. So we have some 40s here, some 50s, and some 60s. I can't see any other values there, so I'll pick 40s, 50s, and 60s for my stems. And then we have to go and find all the 40s, 50s, and 60s. I'm going to do this in order, so I can get an ordered stem and leaf. There is the option of doing an unordered stem and leaf diagram first of all. So I'm looking through all my 40s. I've got a 43, a 45, and 2 47s. So I'll start with my 43, then my 45, and then my 2 47s. Now my 50s, I can instantly see that there's a 50. Now we've got a 53, and another 53, 55, 56, 57, and 3 58s. A 61, a 62, and a 62. And just as a quick check, it said that we had 16 eggs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The first thing I noticed about this question is that we have a straight line here, and this angle is 110. I know angles on a straight line must add up to 180, so I'm going to work this one out. I reckon that is 70 degrees. I'm just going to put down that angle TQP is 70 angles on a line make 180 degrees. This is an isosceles triangle. We can tell this because we've got this dash here and this dash here indicating these are the same length. So these two angles must be the same. So this one here must be 70 degrees. So angle PTQ equals 70, and we know this because this angles in isosceles are equal. And finally, you'll notice we have 3 angles here in a triangle. So 70 plus 70 is 140. I know these three angles make up 180, so the final answer must be 40 degrees. 40 degrees, 180 take away 70, take away 70. And the reason being, TPQ equals 40, because angles in a triangle make 180. Every step of the way that we have explained what assumptions we have relied on, angles on a straight line, base angles in isosceles, and finally angles in a triangle. Okay, just reading this graph, it looks like this axis is the distance away from home. So 0 kilometers represents Nigel's home. So anywhere along this line, Nigel is at home. This must be where he's leaving because he's going away from home. So we have to understand what this time is here. I'm going to say that that is 10, 10. Somewhere in between 10 and 10:20. So that is 10, 10. How far was Nigel from home at 10:20? So we go up from 10:20 and we go across. That looks like 3 squares up from 10. Seems 10 squares represents 10 kilometers, so each square is 1 kilometer. That makes that 13. So 13 kilometers. Oh. Nigel arrived home at 11:50. Complete the distance time graph. So 11:50 is here, and I'm drawing this cross on the bottom because that's where his home is. This is where he started out, and we draw in a straight line like that. The best way to answer any transformation question normally is to use a piece of tracing paper. So I'm going to put the tracing paper over my shape and my cross. I'm going to mark the cross and I'm going to trace out the shape. Now the instructions are rotate triangle T 180 about the point 10. Well, the point has already been marked, so we want 180 degrees. 180 degrees is a half turn, so that means this page will be brought around to the bottom. So we're going to go around this way, and it's going to appear there. So we just have to remember where that point is on the shape. There's 2 squares beneath the cross it's starting off, and then this point is there. This point is here, and then we draw our shape carefully. It also tells us to label our shape A, so there we go. Okay, this is another transformation question. Looks to me like an enlargement, so we need to find this scale factor, and we also need to find the centre of enlargement. So just looking at a length here, I think that this width here is 2, and the corresponding width on this one is 4. So if we consider that 4 divided by 2 is 2, the scale factor is 2. So we're going to say it's an enlargement. That's the first mark of 3. Scale factor 2. Now we need to find the centre of enlargement, so what we do is we get 2 corresponding points, one on the small shape, one on the big one. and we draw a line. Now the line is going to start on the big shape, and it's going to be drawn through the line on the small shape and past it. We're going to do the same with another 2 points, the bottom right hand corners of both. And you should find that they meet. We can draw in more points, and you should find that they all meet. The coordinate then is this one here, 1 along and 0 up. So we say about 1, 0. Question 7 is a ratio question. We want to split this into the ratio 2 to 3. So £40 into the ratio 2 to 3. That means that we are going to split it up into a total of 5 parts. So if we do £40 divided by 5, that is £8 for every part. So the 2 parts at the top is 2 lots of £16, and the 3 parts, the 3 from up here, is going to be 3 lots of 8, which is going to be £24. So the first one here, the 2 is for Anna, and the 3 is for Bill. So Anna gets the amount, and Bill gets the larger amount. This is a survey about the number of CDs that 60 students have. These 8 students didn't have very many CDs. They had between 0 and 4. These 18 students up here had loads of CDs, 20 to 24 in their collection. You can imagine the first 8 students are in this category. The next 11 students are in here. So in between these two categories, we've got 19 students. The next category contains the next 9 students. So in these 3 categories, we have 8 plus 11, that's 19, plus 9, that's 28 students. The next category is the next 14, so 8 plus 11 plus 9 was 28, add the 14 is going to be 42, and finally we've got the rest of the students, so add on 18 to 42, that's all 60 students accounted for. So the median, you would imagine, would be student number 30. Now, student number 30, being the halfway point, is not in here, that's the first 8 students, not in here, that's the first 19, not in here, that's the first 28. So it must be, that student must be in the next category up here. So I'm going to say that they are in the 15 to 19 category. They couldn't possibly have been in these categories because that was only the first 28 students. On the grid, draw a frequency polygon to show the information being given in the table. So, number of CDs, 0 to 4. Now we're going to pick a midpoint here. We're going to pick that as 2. A midpoint here, 7, 12, 17, 22. And I'm going to plot this 2 here against this 8 here. So go 2 squares along, and we're going to go 8 up, and that is the first student plotted. The next one, 7 and 11. Next one, 12 and 9. Next one, 17 and 14. And the next one, 22 and 18. And we join these points up. and that is our frequency polygon. Notice that each time we have gone right in the middle of the range, so we plot the midpoint against the frequency. Question 9. Right, if you look here, it's a question about volume of a prism, and if we go back to the beginning of our test paper, we'll see that we've got a formula for volume of a prism, and it says area of cross section, which is the area of the shape at the front, times by the length. So the shape at the front, the cross section, is this area here. It is a triangle. So I'm going to say the area of cross section equals 3 times 4 divided by 2. Remember, it's the area of a triangle, so don't forget to half. 3 times 4 is 12 divided by 2 is 6 square centimeters. Now all we do is multiply by this length here, 20 centimeters. So volume equals 6 square centimeters times by 20 centimeters. 6 times 20 is 120 centimeters squared times centimeters are centimeters cubed. This is a written multiplication question, so I'm going to write this using a lattice multiplication method. You can use whichever method suits you best. Now it is worth 3 marks, so it would be a shame if we got the answer 1 digit out and we lost all our marks. So it is useful to show you working, and that's why you really should pick one of these methods rather than doing something informally in your head. So we've got 4.52 times 36, 2 times 3 is 6, 5 times 3, 15, 4 times 3, 12, 2 times 6 is 12, 5 times 6 is 30, 4 times 6 is 24. We are going to add up all the different columns. I say columns, diagonals, so it's those 3 diagonals and those 2 diagonals. So this diagonal is going to be 2. This diagonal, we've got 6, 1 and 0, that adds up to 7. This one adds up to 0, 5, 3, 4, that's 12 it adds up to. So we're going to put the 2 there, and I'm going to carry the 1 into the next column. So that is 1, 2, 2, that's 5, plus 1 is 6, and then that one there is just 1. Now, I've got this number here, 1, 6, 2, 7, 2, and that will get you several of the marks. However, we need to think about what effect this decimal point has. So what I'm going to do is think about that as an estimation. So 4.52, that's roughly 5, and 36 is roughly 40. So 5 times 40 is 200. So I'm looking for an answer somewhere in the hundreds region. So let's have a look at this number and let's think where to put the decimal point. Well, if I put it there, it would be 1 point something. I don't want 1 point something. If I put it there, it's going to be 16 point something. If I put it there, it's going to be 162. Now, there's the key word, hundreds. So I'm going to put that there. The method that you're supposed to use with this method to easily do decimal multiplication is to just drop this decimal point down to there. Okay, there are 300 people in a cinema. 1/6 of them are boys, 3/10 of them are girls, and the rest are adults. So we need to go 300 divided by 6 for the boys, which is 50. So there's 50 boys. For the girls, we want 3/10, so we're going to do 300 divide by 10 and then times by 3. 300 divided by 10 is 30, times 3 is 90. And the rest are adults. So, adults, well, we know that there was 300 people in total. We're going to take away the boys, and we're going to take away the girls. 300 take away 50 is 250. 250 take away 90 is 160. Right, this requires a useful bit of knowledge here that all of the angles, the exterior angles on a polygon add up to 360 degrees. These are all the exterior angles. These things here. And they add up to 360. There are 1, 2, 3, 4, 5 of them on a pentagon being a 5-sided shape with 5 angles. So 360 degrees for all of them, divided by 5 is 72 degrees. The questionnaire question now. Anil wants to find out how many DVDs people buy. How many DVDs do you buy? Well, this could be over the course of a month or a year. It's very vague, the question. So really, we want a time frame. So we would want a question that was like per month or per year or something like that. That would be a better question. So I am going to say there is no time frame. Let's look at his options. 1 to 5 DVDs, 5 to 10 DVDs. Well, instantly I can see that this number is repeated twice. If somebody wants to say 5 DVDs exactly, which box do they pick? It's ambiguous. So really what would have been better is if they did something like 1 to 4 and 5 to 10. Oh, we've got another overlap here, so then they would have had to have gone 11 to 15 and 16 to 20. So there is overlap. And the last thing is that there are a few gaps. So what happens if somebody says 0 DVDs? So we should have changed that to 0 really. 0 to 4 DVDs would have been better. And how about we just go 16 plus for this to cover our bases? So I'm going to put a third thing. You only need 2, but you can pick any of these 3. And I am going to say that there are gaps. The correct terminology for this is that it doesn't exhaust all possibilities, so it's not exhaustive. Going back to this, if you want the official terminology, we say it is not mutually exclusive. And mutually exclusive means that something appears in 2 boxes. They're not just in one. On this question, we're asked to find some values of y given some values of x. So I'm going to do this beneath. I'm going to take my value of x as 1, and I'm going to substitute that in. Y equals 1 squared plus 1, take away 3. 1 squared is 1. 1 is obviously just 1, take away 3. 1 plus 1 is 2, take away 3 is negative 1. So I'm going to put negative 1 in there. Next one, I'm going to do y equals 0 squared plus 0, take away 3. That is 0 squared is 0, 0, just 0, 0 plus 0 is 0, take away 3 is negative 3. So I'm going to put negative 3 there. And finally, I'm going to pick this this one here. We've done those two, haven't we? So y equals. Now this is why we put the brackets in, because I want the negative to go in the brackets as well. Negative 3 squared plus negative 3, take away 3. Remember that negative 3 squared is 9. It's not negative 9, because two negatives multiplied together make a positive. When you're adding on a negative, it's the same as subtracting, so I'm going to change that plus negative 3 into minus 3, and then that negative 3, minus 3 is copied down. 9 take away 3 is 3. On the grid below, draw the graph for values of x from negative 4 to 2. So we just plot these as coordinates. This negative 4, 9 up here is going to be the coordinate negative 4, 9, like that. Negative 4, 9, negative 3, 3, negative 2, 2. Oh, negative 2, negative 1, sorry. Negative 1, negative 3. 0, negative 3. 1, negative 1. And 2, 3. Now I'm going to draw a curve through these. As you can see, it's not a straight line. So to help me, I'm going to turn my page slightly. So I'll do it over arm rather than under arm. Now, this looks like it could be a flat line, but it should be a continuous curve. So it dips below a little bit like that. And there we go. Now, the next question on this says, use your graph to find estimates for x squared plus 3x take away 3, x squared plus x take away 3 equals 0. So we're looking for anywhere where there would be a result of 0. Well, if we look back on our original table, there are no results where x squared plus x take away 3 came up with 0. Otherwise, we would have a 0 in here. However, this is the y coordinate. This is a y coordinate of 0 anywhere along here. That's where that coordinate would have featured. So really what we're talking about is that point there and that point there. Both of those have y coordinates of 0. So if we just take a reading off here, I think that that is about 1.3, and I think that's about negative 2.3. Now the examiner will give you a little bit of leeway here. There are two answers, 1.3 and negative 2.3, there or thereabouts. Right, in order to express this as a product of its prime factors, we have to split this number up into two numbers to begin with, two factors. So we start with 180, and I'm going to split that into 2 times by 90. Now, the key word is here, prime. Prime, 2 is a prime. This number is not a prime, so we continue. 3 times 30, these are the factors of 90. 3 is a prime. 30, 3 times 10, 10, 2 times 5. Every time we reach a prime, we draw a circle around it. Now it said the product of its prime factors. These are the prime factors, these things in circles. So the product is where we times things together. So 2 is a prime factor, 3 is, 2 is, and 5 is, and we want to see all these multiplied together. So we can write 2 times 3 times 2 times 3 times 2 times 5. Or we can write it in a different order, 2 times 2 times 3 times 3 times 5. Or even better, we can write it as, this is 2 squared, this thing here. This is 3 squared, and this is 5. Any of these answers would be fine. Okay, in order to multiply these two fractions, first of all we have to convert these to top-heavy fractions. So 3 1/4, well, if we think about in terms of what it's made up of, 3 whole ones and 1/4. Now I'm showing the 3 whole ones split into quarters so that we can see what a quarter looks like. There's the 3 whole ones, there's a quarter. 1/4, 2 quarters, 3 quarters, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So really, another way of describing would be 13 quarters. Another way to do this is to go 3 times 4, which is 12, add 1, which is 13, and then just carrying the 4 down. So I'm going to do exactly that on the second one. 2 times 6, add 2 is 8 over the 3. Copy this times sign down, so I'm saying that fraction is the same as that fraction. Now it is simply a case of doing 13 times 8 on the top and 4 times 3 on the bottom. So that is 13 times 8, 104, and 4 times 3 is 12. Do all that little techniques of present it in its simplest form. So I can see that both of these are even, so I'm going to divide by 2. That's going to be 52 divided by 6. Even, so that is going to be 26 divided by 3. Now, I can't see any common factors here. The only factor that I can divide through with any meaning here is 3. So 26 divided by 3 unfortunately doesn't go. About what 26 thirds is. 3 thirds whole 1, and 6 thirds is a whole 2. 9 thirds would be 3, 12 thirds would be 4. How many times can I fit 3 thirds into this? Well, 24 thirds would be a whole 8. 24 thirds would leave me 2 thirds left over, so the answer is 8 and 2 thirds. Okay, on this question we're looking for a common factor of these two terms. So the common factor here, I can see that both of these are in the 3 times table. And there's 2 terms, so I'm going to put a bracket here. Now I've got to think 3 times something, 3x, so 3 times x, and 3 times something is 12. So I'm going to think 3 times 4 is 12. Now I can check this doing brackets. 3 times x is 3x, 3 times 4 is 12. On this next question, solving equations question, I can see I've got unknowns on both sides here. It's quite a tricky question. So first of all, I'm going to deal with this bracket. So I've got just unknowns and constants on both sides. So 4 times 2x is 8x. 4 times negative 3 is negative 12. Just copy the right hand side down. Now, that's a bit easier to deal with now. So I notice this negative 12. I want to get rid of this negative 12. So I'm going to add 12 to both sides. So the left hand side of my equation, the negative 12 or the minus 12 goes. On the right hand side, 5x plus 7 is going to become 5x plus 19 when we add 12. Right, now I'm going to take away a number of x so we can solve this problem of having unknowns on both sides. So I'm going to take a smaller amount of x away, so I'm going to take away 5x from both sides. 8x take away 5x is 3x, and if I take away 5x from the right hand side, all I'm going to be left with is the 19. The 5x disappears. Now, that's what 3x is. I want to find out what x is, so I'm going to divide by 3. So if I divide 3x by 3, I get x, and if I divide 19 by 3, I get 19 thirds, quite simply, and that would be fine as a if you want to convert that to a mixed number. 3 goes into 19 6 times, remainder, so it's 6 and a third. To expand and simplify this one, it is multiplying a pair of brackets. So the first two terms multiplied together, that is going to be the outer terms, that is 5 times y, that is 5y. The inner terms, that's 4y. And the last terms, which is 4 times 5, 20. Now, the two terms that we can join together are these two middle terms. We are going to change that into 9y, so we are left with y squared plus 9y plus 20. Right, the last part, just like the first part, it is a factorised question, except it's got a few more common factors. The thing that I notice is that we have an 8 here. They're both in the 4 times. I'm going to take 4 out as a factor. There are y's in this one, but there are some y's in this one, but that means that there's no common factor of y. There is an x in here though, and there is an x in here as well, so I'm going to take x out as a common factor. Now think what you need to multiply 4x by to make 8x squared. 4x times 2 would make 8x, and 4x times 2x would make 8x squared. 4x times what would make 12xy, times 3 would make 12x, but we need to introduce this y as well. So 4x times 3y would make 12xy. Okay, these two shapes are mathematically similar. That means that there is a scale factor between them for their enlargement. So what we need to do to find a scale factor is find two corresponding values. I can see a 6 centimeters here and a 4 centimeters on this shape here. So if I do big divided by small, I get 6 divided by 4, which is 1.5. So scale 1.5. Now I need to work out QR. So QR here. And if I look at the corresponding side on this one, that's BC. So BC is 12 centimeters. If I do 12 times by 1.5, that is 18 centimeters. Now, to work out the length AB, that is this length here, and that is corresponding to this length here. So, I'm going to use my 1.5 scale factor, and I'm going to use it on this 15 centimeters. But I have to make this number smaller than this, so multiplying by 1.5 wouldn't work. In this case, I'm going to divide by 1.5 to find out this new value. So 15 divided by 1.5, that is 10. So Arwen buys a car for £4,000. The value of the car depreciates by 10% each year. It loses value. So £4,000, and we want 10%. So we're going to divide by 10. It's £400. So at the end of year one, it is going to be £4,000 take away £400. It's going to be £3,600. Now at the year two, we're starting off with 3,600. We're going to divide that by 10, and then that is going to be 360. Notice it didn't go down by 400 again this time, it just went down by 360, so you do have to do the calculation separately. You can't just take away £400 twice. So that's 3,600, take away 360, so that is 3240. Okay, this question isn't on the current specification of an exam, but I'll do this anyway. Lengths, pi and 4 are numbers that have no dimensions, could represent volumes. Well, we know that volume, for instance, of a cube, and here's a cube, is in a length times a length. For instance, we could have 2 meters times 2 meters. That would be 2 times 2 times meters times meters times meters is meters cubed. Notice that this is the unit of measurement of volume, meters cubed. We can have anything, any measurement of inches, we can have centimeters, as long as it's cubed. It has to be 3 lengths by each other. So that's anywhere we've got 3 lengths multiplied by each other. So A is a length and B is a length. This is a length times a length times a length, but then times another length. So that's a 4-dimensional object. That is not what we are looking for. Now this looks like it's got 5 lengths involved here. Sorry, 4 lengths. 1, 2, 3, 4. However, when you think about the multiplication, if you multiply this out, this is a squared times c plus a squared times b. Now a squared times c is times a length, and a squared times b is a length times a length times a length. So that is a volume, and that is a volume, and this is just 2 volumes added together. So that is what we are looking for. This one here, this number we are told down here, it is a number with no dimension, so it's just 4 lots of whatever this is, and this is a length times a length times a length, so that is a volume. This one here, this thing here is a volume. We can see that it's a length times a length times a length. We can see this classic number 3 here indicating volume. However, we've got A times B here, a length times a length. There's no third length, so that is an additional shape. And finally, we've got this one. Now, don't be fooled by the fact that we've got this symbol here, pi. It says here pi and 4 are numbers that have no dimensions, so we can effectively get rid of them. What we're left with is c squared, which is c times c, which is an area. So that is not what we are looking for. Now, we've got volume scale factor. So we are going to convert from 8 cubic meters to centimeters cubed. There's 2 ways that you can do it. First of all, I would look at this and go, well, that's 2 meters, that's 200 centimeters, and then this is 200 centimeters, and this is 200 centimeters. So if you go 200 times 200 times 200, 2 times 2 times 8, and 100 times 100 times 100 is a million. So 8 million there. So it's 8 million centimeters. The alternative is to get from here to here. Meters to centimeters would be times by 100. Because this is these are both cubic measurements, we're going to scale factor cubed. So 100 cubed is a million. So 8 times a million is 8 million centimeters cubed. Okay, before we solve these simultaneous equations on question 21, we are going to label these equations A and B. Now the trick is to get a common value in each of these, a common coefficient of x or of y. So I'm going to do that through in these both into 6x. So I'm going to double equation A. I'm going to get 6x plus 4y equals 16. I'm going to triple equation B. So that is going to be 6x plus 15y equals negative 6. Now if I do 6x take away 6x, I'm going to eliminate that variable, and that's exactly what I want. If I do 15 take away 4, that's going to be 11. If I did 4 take away 15, that's going to give me a negative. So I'm going to try and avoid that. So 54. So I'm doing 3b take away just. Oh well, tip here anyway. So negative 6 take away 16 is negative 22. Now I've got 11y equals negative 22. See that means that y is negative 2 if I divide both sides by 11. Now that I know y is negative 2, I'm going to look back at one of my equations. If I look back at 3x plus 2y is 8. So 3x plus 2y. Now we know what y is. Y is negative 2. So instead of writing 2, I'm going to write 2 lots of negative 2. Now I'm going to solve this. 2 lots of negative 2 is negative 4. So add negative 4 is going to be like minus 4. That equals 8. 3x equals 12. I've added 4 to both sides, and that means x is 4. Now the alternative was to get the y, so I could have multiplied equation A by 5, 15x plus 10y, and the second equation by 2, and this equation take away this equation. Notice that I've got 10y in it. I did the multiplications I did. 15x take away 4x is 40 take away negative 4. Now, 40 take away negative 4. Taking away negative is like adding, so don't put 36 there. You are taking away, so this is an addition. 11x equals 44, that means x is 4. Let's pop this back into the first equation, so I'm going to go back to the beginning. 3x. Right, instead of x, I'm going to put 3 lots of 4 plus 2y, it says, equals 8. 3 lots of 4 is 12. 2y is 8. Take away 12 from both sides and divide by 2. Notice either way I do it, I get x is 4, y is negative 2. Write down the modal class interval. Well, the class intervals are these things here, with these inequality sign. So this is about the delays of AT flights. So class interval is a category in minutes for how long the delay was. So was it not very long, 0 to 20, or was it ages 50 to 60 minutes? The modal one is the one that appears the most often. So modal is a word linked with mode. So the mode one is this one here, the modal one, and the class interval is that one there. So we write down the class interval just as it is written down there. So the majority of the delays were between 20 and 30 minutes. Now, cumulative frequency. First of all, we've got one entry that is very easy. The delay between 0 and 20 minutes we've already got. It's 6. The 0 to 30 category. Well, the 0 to 30 category is on this first table. It's the 0 to 20 category and the 20 to 30 category. So it is the 16 plus the 26. So that is 30, 42. The 0 to 40 category is the 0 to 20 plus the 20 to 30 plus the 30 to 40. These two numbers, which we've already added up, getting us 42. Add this one and we get 65. Now you will notice I'm just adding on the next number. So this one is going to be 75 and this one is going to be 80. So on the grid opposite, draw a cumulative frequency graph for our table. So we know that after we have accounted for 16 of the flights, so we plot at the end of the range. So it's really this number here that we're plotting against this number here. We don't go for the midpoint like we did on the frequency polygon, it is the end of the range. The 30 is plotted against 42. The 65 is plotted against the 40. And the 50 is plotted against the 75. And the 60 is plotted against the 80. And you'll notice there's big jumps here and then there's a small jump right at the top. Right, we can draw a smooth curve on this. I like to also join the dots to 0 as well. So I'm going to just draw a smooth curve like that. Just ruler is a rough approximation for this curve that I've produced here. As long as you've got a curve, that gets you both marked. Right, on this question, down here, part D, it says, use your graph to find an estimate for the median delay. Median delay is going to be the delay of the 40th flight, since the flights were in order of how long they were delayed for. 2 is 40, is, so if I put down this in 9 minutes, says the now the interquartile range relies on two values, that is the upper quartile and the lower quartile. It's a little bit like the median, except it's not halfway, it's a quarter of the way. So a quarter of 20 is, a quarter of 80 is 20. So you can see that the lower quartile is 22 minutes. The upper quartile is 3/4 of the way along. And then dropping a line down, it's like 36 minutes. So we've got 36. The interquartile range being the difference between the upper quartile and the lower quartile, and that gives us 14. Okay, in order to find out the equation of a line, there's two things that I want. Equations of lines are always in this template, y equals mx plus c. And this thing here is the gradient. And this thing is the y-intercept. So the gradient I find by drawing a little triangle on. And I look at these two y coordinates and I think, right, well, this triangle, it's gone up from -2 to 10. So that is a height of 12. And if I look at the x coordinates, the first numbers, I go from 0 to 3, that is a distance of 3 across. Now, I do rise over run to get, it is 12 divided by 3, so it is 4. So I know that this equation has got a gradient of 4, so it's going to be y equals 4x plus the y-intercept. The y-intercept is where it cuts through the y-axis. So you can see here the line cuts through the y-axis at -2. So it is simply y take away 2. Don't forget to put the y equals, it is an essential part of the equation. And Question 24, I'm asked for 6 to the power 0. Remember that anything to the power 0 is 1. The reason for this is, you imagine 6 squared is 36. 6 to the power 1. Each time here we are dividing by 6. So is 6 divided by 6, so that's 1. 64 you're required to know that 64 to the half by 64 to the half must be 64 to 1. In other words, to get 1, which is just 64, we need a number multiplied by itself. Well, this is the definition. So really, 64 to the half is the sum. You can just memorize this. So square root of 64 is 8. I would memorize both to the power of half and to the power 0. Just gives you 1. On this one, we've got this line. We've got the to the power 2 and to the power of. So we'll go through it in order. First of all, now the minus sign reciprocal of whatever the base is. So the reciprocal of 20 is 8 over 27. The negative has been used up now, so that is 2 over 3 rather than negative 2 over 3. Right, I'm going to do apply this power of a third here. The power of a third means the cube root of 8, and the cube root of 27 is 3. Now we've used up this 3 here, third, so I'm just going to write the 2, so that is 2 on its own now. And we're going to apply this now. 2 squared is 4, and 3 squared is 9. So your final answer, 4 over 9. Question 25. We're asked to show that this equation is true. I'm looking at this triangle, I'm thinking this looks a little bit like Pythagoras. So Pythagoras says the square of the hypotenuse is the sum of the squares of the other two sides. So we need to add up the squares of these two. So we want x squared plus x plus 2 squared. This one here, we use FOIL, x times x, 4 times x plus 4 times x, that is 8x. 4 times 4 is 16. This side, copy the x squared down from here. Multiply out this bracket using FOIL. X squared plus 2x plus 2x, that's plus 4x. And plus 2 times 2 is 4. This is a bit of a mess at the moment. X squared plus 8x plus 16 equals x squared. X squared plus x squared is 2x squared plus 4x plus 4. Now I want to take everything over to one side, so I get an equal 0. So I'm going to take away x squared from both sides. I'm going to take away 8x from both sides, and I'm going to take away 16 from both sides. So on one side I'll just have a 0. So on the other side I get x squared. 4x take away 8x is negative 4x, and 4 take away 16 is negative 12. So that equals 0. Solve that equation. Right, so we're going to factorize that. We're going to have x and x. I'm looking for two numbers that multiply together to give me negative 12. So I'm thinking it could be negative 1 and 12, it could be negative 2 and 6, negative 3 and 4. That's about it. Or it could be 1 times negative 12, 2 times negative 6, or 3 times negative 4. All of these pairs of numbers multiply together to give me negative 12. I want a pair of numbers that will add together to make negative 4. So add them together, that makes 11. That's not it. That's positive 4. That's 1 when you add them together. Negative 11, negative 4. So it's those two numbers. So it's plus 2 and minus 6. Now, in order to make these two lengths multiplied to give 0, one of these must equal to 0. 0 times something is 0. So either this bracket can be 0, in which case x is negative 2, or the second bracket can be 0, in which case x is 6. So x is negative 2 or 6. Hence write down the length of AC. Well, AC, it says x plus 4, so we could either have negative 2 plus 4, which would be 2, or 6 plus 4, which is 10. Now, there's only room for one answer here, so which one can it be? Well, we had values here of x as negative 2 or as 6. Thing is, we can't have a length of negative 2 for this length here. This is just x on its own, so it doesn't make sense to use this answer here of negative 2. So we'll strike this one out and we'll just use this one. So that is 10 centimeters. On this question, we want to draw a probability tree diagram. There are three options available every time we take a suite. We've got orange, we've got red, and we've got yellow. So we draw for the first pick a 3-branch tree diagram, and for the second pick we draw another 3 branches, but we are going to have to draw that 3 times to represent the 3 different things that happened the first time. Now do bear in mind that on this question it says that she's eaten the sweet, so that means that the number of sweets is going to go down after the first pick. The first pick is all out of 10. Initially there are 10 sweets in the bag, so the chance of getting an orange sweet is 3 out of 10. The chance of getting a red sweet is 2 out of 10, and the chance of getting a yellow sweet is 5 out of 10. Now, if orange sweet has been picked, there is one less orange sweet in the bag, so there are only 9 sweets in total. Now this goes for everything, doesn't it? There will be 9 sweets no matter what has happened the first time. Do bear in mind this is 9, not 8, because this second branch is slightly before the second sweet has been picked. So that's why it's 10 to begin with, even though we are talking about the first sweet being picked. So it goes down one at a time when you're doing tree diagrams. So the first sweet was orange. There was 3 orange sweets, now there is 2. The number of yellows and reds is still exactly the same. So there were 2 reds before, there are still 2. There are 5 yellows before, there are still 5. Now you should find that these add up to 9. 2 plus 2 plus 5 is 9, so that's the 9/9 for that one. Now a red sweet has been picked here on this middle branch, so the number of red sweets has gone down from 2 to 1, so in the middle branch that is 1 out of 9. I really should label all these as well. And the other numbers have stayed the same, so that is going to be 3, and that is going to be 5. And finally on this one, the 5 out of 10 will have gone down to 4 out of 9, and the other 2 numbers will have stayed the same, 3 and 2. Work out the probability that the sweets are both the same colour. Well, that's this branch here, orange and orange. It could be red and red, or it could be yellow and yellow. So we want those multiplications. 3 times 10 and 2 times 9. The reason that we're doing these multiplications is because the probability of 2 things happening, of one thing and another thing happening, is where we multiply them. Now I realise I can cancel down these fractions, but it's best not to, because I'm going to be adding them in a minute. And to add we need common denominators. So we want all three of these things, any three of these things. The probability of things happen, one thing happening or another thing happening is where we add them. And that's your final answer, 28 out of 90. You can simplify that, but you don't have to. Last question on circle theorems. So calculate the size of the angle OTQ. That is that one there. Right. This says that we have a tangent. So I'm going to use what I know about tangents. I know that tangents meet radii at 90 degrees. So if this is 58, this angle here must be 32. So I'm going to put OTP equals 32 because radius and tangent meet at 90 degrees. Right, I know that this angle here, this 58, and this angle here are the same. And the reason I know that is because this is angles in alternate segments. So I am going to say that PQT is 58 degrees because angles in alternate segments are equal. Right, finally, I see that this is an isosceles triangle. So I know that these two angles are the same. So angle QCP is going to be 180. Take away 58, the 58 of this angle here, and then I'm going to divide it by 2. 180 take away 58 is 122, divided by 2 is 61 degrees. So I know that because angles in a triangle make 180. That's where this 180 came from. And this angles in isosceles are equal. That's how I knew to divide by 2 to get these two. So if that whole thing is 61 now, and I know that bit's 32 from my reason before, I can say OTQ equals 61 take away 32, which is 29 degrees. And I've stated all the reasons why I've done that. And that's the end of the test.